Here's the solution to question 2 of homework 5. There are 4 problems to solve. Let's begin the first problem. It's drawing the non-zero definition region of the density function. Because y is larger than or equal to 1, so we can find y minus y equals to 1, and we must take the above this line. And because x is larger than 1 over y smaller than y, first we find y equal to x is this line, and we have to meet the requirement of y is larger than x, so it's above the line, so it's this way, this square, and we can find the curve of y equal to 1 over x is this curve, and because x is larger than 1 over y, means that y is larger than 1 over x, so it's the right side of the curve. So above all, add them together, we can get the shader. The area of shader is the non-zero definition region. And let's begin the second question. Is finding a so that the density function is a very joint density function, and because the density function is a very joint density function, we can get the integral of the density function equals to 1. We can get this equation from the title, and then we simplify this one, we can get this equation, and in order to get the result, we let z equals to num y. It means that y equals to ez, so we can get this equation, and then we do the integral, we can get 2a equals to 1, so a equals to 1 over 2, and this is the solution to question 2. And let's begin the third question. Is finding and drawing the marginal density functions. We can know that the density function x equals to the integral of f(x) and y, and we can know that y is larger than or equal to 1, and y is larger than 1 over x, or y is larger than x. And for x is larger than 0, smaller than 1, we must meet the requirement this one, so we choose this region, so we can get this integral, and we can get the result 1 over 2. And for x is larger than 1, smaller than unlimited, we can know that we can get the integral of this. We choose the y that is larger than x, because y must be larger than or equal to 1, and x is larger than or equal to 1. So we can get this result. So the final result of the density function of x equals to 1/2 for x is larger than 0, smaller than 1, and equals to 1/2 times x squared. For x is larger than or equal to 1, smaller than unlimited, and 0 else. Else means that other situation. Other situation. And at the same way, we can get the density function of y is the integral of fxy, and we can know that x is larger than 1/y, smaller than y. So we can get this integral and get the final results for y is larger than or equal to 1. So we can get the final density function of y equals to ln y/y squared for y is larger than or equal to 1, and other situation equals to 0. Through the expressions, we can draw the figure. These two figures express the marginal density function. And let's begin the final question. Is verify the density function are very density functions. And because we can integrate because the integral of density function equals to 1/2 plus the integral of this one, and we can get the final results equals to 1. So we can get the density function of s is a very density function. At the same way, we can prove the integral of density function of y equals to 1. So we can get the density function of y is a very density function. This is the solution. That's all. Thank you.